We have completed Narnia 5. So this time we will be looking at Narnia 6. So we know where the data is. So ls-l. So our point of interest is this one. So let's see what this Narnia 6 actually does. Looks like it's just printing the usage of Narnia 6. Okay, so it's expecting two arguments. So let's try to give two arguments. So let's say ASDF1 and ASDF2. So it's just trying to reply ASDF1. Interesting. So what about ASDF2? It doesn't care about ASDF2 as of now. But maybe inside the program, it cares for second argument as well. So let's look at this file. So this is the standard headers, and we have already seen that this regards to environment variables and some comments. Tired of fixing values, Morla, unassigned long get sp void. Okay, so it's trying to define function get sp, which has some instruction over here. So this instruction says that move stack pointer to EAX register. Okay, let's check this out. So look at here, this is the case. So if this is the case, moveL actually moves variable value to the EAX register. Okay, so it says move the contents of the memory location of var into number register EAX. Okay, so this is what's happening over here as well. So whatever it's there in the memory, this memory location will be transferred to EAX register. So basically we control the stack pointer, right? So whatever we input actually goes into stack pointer. So we control this stack pointer. So if that memory location is transferred to EAX, we can try to execute some instruction using this. Okay, so let's come down. So this is the main function. It accepts some arguments. B1 and B2 can accommodate 8 bytes of data each. Here we have FP. So basically that FP is just file pointer. So whatever is pointed towards that FP will be opened and shown to us. Okay, so this FP pointer is given as location for puts. Okay, so puts is basically something like printf. Okay, so it's just prints whatever input is given to this. Okay, so basically this FP will act as puts as of now. So at the end, FP is returned back to us. So FP is acting as printf right now. So this function is calling B1. Okay, B1 is basically the first argument, right? So that is what is returned to us previously. Okay, so when we gave ASDF1, this is the B1. So B1 is returned back to us. So that's what this statement does. So this one, it is checking if it has two arguments or not. Okay, so argc is not equal to 3, which means the name of the file and then first argument and second argument. Okay, so basically this is argc of 0 and argc of 1 and argc of 2. Okay, so basically 3. If it is not equals to 3, then it is going to print the usage and then it exits over there. Okay, and then they have given a comment, clear environment variables. So it's going to remove all the environment variables. And next statement is clear arguments. Okay, so it's going to remove some arguments. It's not going to remove all the arguments. So it's starting with I equals to 3. Okay, so which means anything more than 2 arguments will be removed from here. Okay, only 2 arguments will be taken into the memory. So that's what this is. And once this is done, argument 1 will be moved to B1, argument 2 will be moved to B2. And you have to also remember that the string copy does not have any restrictions on how much this argument can be and how much this argument can be. Okay, so whatever is given in argument 1 will be stored in B1. Even though it can only store 8 characters, whatever is excess will be moved to the next one. Okay, so whatever is stored in B2 will be stored only for 8 bytes and whatever is excess will be moved to different location in memory. Okay, so that's what this is. And then it's checking if it is going to get any stack pointer or not. And then it's going to exit right here. If it doesn't, then it's going to set the effective user ID of the program and it's going to set the user ID. And once it is done, it's going to exit out here. Okay, so this is the main thing. This is where the vulnerability is. So let's see what we can do using GDB. Narnia 6 and enable debugging and here we are. Okay, so let's say disassemble main. So it's gonna just disassemble all the main. Okay, this time we have a huge number of instructions. So let's go back. So initially it just prints out the instructions of how to use it and exit over here, and it has some main things that needs to be set and memory set. This is where you're actually removing environment variables, and there has to be one more mem set. This is where you're actually removing extra arguments, more than 2 arguments. This is where you're copying B1, and this is where you're copying B2. Okay, it's gonna get effective user ID, and it's gonna set effective user ID right here. Okay, and once everything is done, it's gonna exit. Let's keep a breakpoint right here in this call instruction. Okay, so let's say break star main plus 316. Okay, you don't have to remember this, you have to remember only this part. Okay, and hit enter. So we have created a breakpoint. So let's give normal values like we did before. So this time we know that it can accept 8 bytes in B1 and 8 bytes in B2. Okay, so to differentiate, we will keep 8 A's and 8 B's. So let's run this and let's see what happens. So we have reached the breakpoint. So let's type info registers to see whatever is there in the registers. Okay, so these are the list of registers. Here we have something in EX register. This is the stack pointer. So let's see the data in stack pointer. Examine 10 words of memory from stack pointer. This is 8 bytes of B, and this is 8 bytes of A, and looks like B2 is separated from B1 by a null character. Just after B1 we have this in the memory. Okay, so what is this? This is EAX register. Okay, so can we override this EAX register by overflowing B1? So let's try that. We'll just override this. Okay, so let's keep 4 C characters. So the C characters represent 43, 43, 43, 43. So this 43 has to be replacing this EAX register. Okay, so let's see if it happens. Let's hit yes, and we have reached a breakpoint. So let's check info registers. We can see that EAX registers now have C characters over here. Okay, which means we can give any address in memory to this particular EAX, and it would execute whatever is there in that memory. So using this, let's try to get something that we can execute. Okay, we know that the system function can execute any command that we have given. Okay, so this is the default bash function. Let's try to get its location. So to do that, we will ask for a pointer of system. Okay, so it just gives this location in memory. Okay, so let's copy this and save it right here. If we overwrite this EAX register with this system memory, we can execute any system command. Okay, so let's give this address to EAX register. So let's run. So this time we have to pre-process this address. Okay, so to do that, we'll use echo. So let's say echo -e, and we'll just run a, and just after that, let's give 4 bytes of this memory. We'll say x30. We'll give it in little endian format. So we'll say d4 xdc and \x f7. Okay, so we'll close this and we'll give a space, and we'll write 8 B's over here. Okay, so 1 2 3 4 5 6 7 8. So these characters doesn't need to be A's or B's. Okay, these can be any random characters. Okay, we'll close this with backtick and let's see what happens. Okay, hit Y and let's continue. Okay, so as you can see, so detaching after V fork from child process this. Okay, which means a child process was created and then it is detached from it. Okay, which means the system has been executing, but it did not have anything to execute. Let's try to overflow this B's and see what happens. So let's give C. So this is also random character. So let's see what happens. We hit a breakpoint. Let's continue. So as you can see, it is trying to execute the seed that we have given over here, which means after this B2 buffer is filled, whatever is there at the end will be given as a system command. Okay, to verify that, let's remove this C and type ls. So we want to execute ls command. So let's see what happens. Continue. And as you can see, successfully executed ls command. So let's try to remove ls and keep /bin/sh. Okay, so let's try to get a shell. So let's continue. Look what we got. So we got a shell. Okay, so let's copy this and use the same payload outside GDB. Okay, so let's exit and exit. So let's run Narnia 6, paste it and hit enter. Okay, so we got a shell, right? So let's type who am I? I'm Narnia 7. So let's get the password 7. All right, we got our password. So I hope you get it, and I'll see you guys in the next one.